The flat Earth theory seems to be making a bit of a comeback in pop culture recently, thanks to the internet's ability to lend a megaphone to just about anyone. I'm sure we've all looked on with varying degrees of amused fascination. However, as the trend grows larger, I'm sure that at some point, the laughter has turned to a nervous chuckle. I can't really believe this, right? At the same time, perhaps some of us have even begun to reflect on things. Hang on a sec. How do we know the shape of the Earth? Well, I'm happy to let scientists share our best answers from the 21st century. In this video, this question. But first, we'll be taking a look at how our ancestors, a quick thanks to our sponsor, Squarespace, from millennia ago, answered for making this video possible. We will begin by investigating what the historical and archaeological record can tell us about what people in the past thought of the world. Some of our earliest evidence can be found in ancient Mesopotamian imagery. As might be expected, these propose varying forms of a flat Earth model. For example, Sumerian and Babylonian depictions portray the Earth as a flat disk, ringed by mountains, floating on the ocean with the hemispherical sky vault resting upon the summits. This roof was punctured by small holes through which one could see the celestial fires of heaven. The pyramid texts of ancient Egypt, which date to the Old, surrounded by eternal seas, kingdom, demonstrate a similar flat. It appears that flat Earth model, with a planar body, concepts of this early model would also leave a record in the religious ideas of the time. For instance, the Babylonians would posit that the Earth must not only be flat, but also hollow, in order to provide space for their underworld. The Abrahamic religions also contain many references to their early flat Earth belief. Here are some common examples from the Bible. He sits enthroned above the circle of the earth, and its people are like grasshoppers. He stretches out the heavens like a canopy, and spreads them out like a tent to live in. For he views the ends of the earth, and sees everything under the heavens. He marks out the horizon of the face of the water. In Revelations, I saw for a boundary between light and 4 angels standing at the 4 corners of darkness. And finally, of the earth, holding back the 4 winds of the earth, to prevent any wind from blowing on the land, or on the sea, or on any tree. These descriptions seem quite similar to the Babylonian belief we have discussed. While there is certainly room to take the religious descriptions as more metaphorical than literal, it is clear that the imagery here drew quite heavily on a flat Earth model that must have at some point circulated through the culture. And while such descriptions of the shape of the Earth would continue to live on in various forms, it wasn't long before humans caught on to the error of their ways. Let's now take a look at how they did so. But before we start, I must state that it will be very difficult to speak definitively about what the historical people in the past thought about a given subject. The record is often incomplete, and at least in the general sense. When we do have data, it often favors the elite over the common folks. As we proceed, I will largely be focusing on the former of these two groups, and using them as a weather vane for the beliefs of the time. That being said, I do want to state that there are a variety of practical ways that anyone throughout the ages could have come to their own understanding of the curvature of the Earth without requiring scientific advancement. Here are some simple methods of direct observation. One of the best test environments would be near bodies of water, where an observer could look out over a large, level surface and compare what they saw with expectations from a flat versus a spherical Earth model. Ships sailing over the horizon are ugly, while a round Earth model would be a great example. A flat Earth model would see their topsails disappear last. A model would have them disappear uniformly. The latter proved true. In the reverse fashion, a ship approaching from sea will first observe the tallest objects on land. Another variant on this would be to attempt to observe a distant object like a lighthouse from ground level, or from a tall tower or mountain. As would be expected with the round Earth, the greater elevation reveals objects further on the horizon and behind the curvature. Another common method would be to look up at the night sky. It was quickly observed by travelers that moving north or south had a rather drastic impact on what was visible. In some cases, objects like the pole star would have moved to a different elevation, while others at home, one could look at the Earth's stars might even be obscured entirely. Shadow on the moon. A bit closer, the projection of a flat Earth would be expected to cast an elliptical shadow, while a round Earth would cast a circular shadow. Again, the latter is true. Since our ancestors were well acquainted with the seas, travel, and the stars, I think it's fairly safe to assume that around the world many common folks would have had the ability to clue in onto the shape of the Earth. At the same time, I don't want to overstate the obviousness of the Earth's rotundity. For centuries, many ancient scholars from India, China, the Middle East, and Europe would continue to posit a vast array of incorrect models for the Earth's shape. Several prominent Greek philosophers of the 5th and 6th century BC, however, their peers would soon have argued in favor of a curved word to say about this: disc or cylinder. Among the Greeks, it was claimed that Pythagoras was the first to originate the idea of a spherical Earth. Born around 570 BC, he was a prominent philosopher and mathematician who contributed much to the early field of natural philosophy. While we don't know exactly how he came about his belief of the Earth's shape, it is likely that he would have relied on some of the simple observations we previously covered. Regardless of this uncertainty, his school of thinking influenced many that would come after him. Plato was one such individual who learned from the Pythagorean community in southern Italy. Upon returning home, the famous philosopher founded his school in his dialogue of Timaeus for Athens and proceeded to teach his students. For instance, Plato writes about the property that the Earth was round of the universe, stating that the Earth was, quote, in the form of a globe, round as from a lathe, having its extremes in every direction equidistant from the center. While the model here is relatively accurate, we are still unfortunately kept in the dark regarding any proper scientific reasoning, as Plato's arguments in the passage are more concerned with the geometric perfection of a sphere with regards to his beliefs on cosmology in general. Luckily, Aristotle, one of Plato's prized students, would provide more details. In his work of 350 BC entitled On the Heavens, he lays out his astronomical theory of a geocentric universe with a fixed, spherical Earth, such as the rounded shadow which the Earth at its center. His Earth projects on the Moon, and the change in stated evidence includes argument in constellations as travelers voyage to northern and southern regions. In addition, he also referenced the effects of gravity by stating that, quote, every portion of the Earth tends towards the center, until by compression and convergence they form a sphere. Interestingly, Aristotle even directly addresses some of the arguments of contemporary flat earthers. Quote, there are similar disputes about the shape of the Earth. Some think it spherical, others think it flat and drum-shaped. For evidence, they bring the fact that as the sun rises and sets, the part concealed by the Earth shows a straight and not a curved edge, whereas if the Earth was spherical, the line of sections of the sun from the Earth and the great size would have to be circular of the circumference, which, seen from in this they leave out of account the great distance on these apparently small circles appear straight. Such an appearance ought not to make them doubt the circular shape of the Earth. Thus, through the work of great thinkers like Pythagoras, Plato, and Aristotle, the round Earth belief began to gain traction. The further spread of Hellenism with the conquests of Alexander and the inquiring Romans ensured that the idea went mainstream. Now that the round Earth model was more commonly accepted, further inquiries about the details of its shape could be made. One of the primary questions would be about its size. This would be answered by the Greek astronomer Eratosthenes in the 3rd century BC, of shadows between two distant points using a simple stick, his at the same time. The clever experiment involved measuring the angle. The basic idea here was that if the sun was very far away, its rays would be hitting the Earth practically parallel to one another. Thus, if the Earth was curved, the result would be a difference in the angles of shadows cast by the sun. By measuring the difference, one could determine the radial angle between the 2 points. Additionally, one could also determine the arc length between the same 2 points by measuring the distance along the surface between them. With these 2 measurements, one could then use this ratio to calculate the circumference of the Earth. With his theory in place, Eratosthenes then went about conducting the experiment. He chose as his 2 locations the scene where he knew that at noon on the cities of Syene and Alexandria on the summer solstice, the sun was direct. The first point was Syene directly overhead and shone down a deep well. Back in Alexandria, he planted a vertical rod at the same time of day. Using the length of the rod, the shadow, and trigonometry, he calculated that the angle of the sun's rays were 7 degrees. Plugging this into our formula, he knew that the distance between himself and Syene would be about 1/50th the circumference of the Earth. Eratosthenes then quickly referred to the results of surveying trips, which reported the value to be 5,000 stadia. Therefore, he concluded, the Earth's circumference must be about 250,000 stadia. This value was amazingly accurate, and, depending 5 to 10% from the true value, depending on the exact conversion of states used, resulted in an error of only future mathematicians would replicate the experiment, or devise other means of calculating the value themselves. Posidonius of the 1st century BC, for instance, would take measurements by referencing the position of the star Chaopus rather than the sun. Thus, the ancient world was soon becoming filled with a growing number of empirically determined data points about the spherical shape of the Earth. This would all prove extremely useful to the travelers and geographers of the period. For instance, Claudius Ptolemy of the 2nd century AD would use the data in his book, Geography. Here he introduced the concepts of latitude and longitude to create a series of projected maps with coordinates would be deeply influential in the development of coordinates for all sorts of important locations of cartography. This seminal work, by the height of the Roman Empire, the Mediterranean world experienced an unprecedented degree of connectivity. This ensured that the findings of around Earth were heard far and wide. Even if the scientific reasons were not shared with everyone, the concept itself seeped into the population's general consciousness. For instance, the Roman Empire was quick to adopt the globe as a symbol of divine imperial power. This round Earth imagery can be found on all sorts of artifacts like coinage. As an example, here's a coin from the reign of Tiberius, showing the emperor's dominion over the entire spherical world. The spherical shape of the Earth would continue to dominate scholarship. The debate moved on to more advanced topics like in late antiquity as a simple like the arrangement of the cosmos, matter-of-fact observation, and yet as today, there would still be individuals bucking the adopted view. Theological opposition was one particular source of opposition. The Syriac Christians were one notable community of flat earthers, while some notable adherents included Lactantius, an advisor of Emperor Constantine, who not only promoted the flat earth concept, but also even went so far as to mock those who opposed him. By and large, however, most learned Christian authors, and virtually all cosmologists of note, agreed on the well-backed sphericity of the globe. With the fall of the Western Roman Empire, however, parts of Europe did experience a resurgence of flat earth belief during the Middle Ages, tribes whose cultures still held to these. This was in part due to the largely antiquated views of a flat earth, scale migration of Germanic and Norse, coupled with the swinging of the civilizational pendulum away from scientific scholarship and towards dogmatic religion. However, I don't want to overemphasize this point, as the idea of a bleak dark age has been pretty thoroughly debunked by modern historians. After all, there would be much continuity in the Eastern Mediterranean, and even great leaps in understanding of the world during the Islamic Golden Age, which we'll be covering in another video. For now, this is where we will end things. I hope you've learned a bit about how far back the idea of a round Earth actually goes, and I'd love to see how the Flat Earth community engages with this sort of rich historical discussion. In particular, I highly recommend that they global experiment online. They try out the simple experiment of Eratosthenes. I wanted to Eratosthenes themselves, or join in on the Thanks Squarespace for sponsoring this video. Their awesome platform makes it super easy to build and customize your own website. They've got a number of great features for your online needs. For instance, Audio Block allows you to embed audio on your site and tag it for iTunes within a blog. This is great for setting up your own podcast. Additionally, as a content creator, you'll be thrilled to hear about their sync feature, which allows you to link up all your social media accounts to the website and post simultaneously across all of them. There's a ton more to be excited about. You can start your own free trial today and enjoy 10% off your first purchase by going to squarespace.com/invicta. A huge thanks is owed to our support video possible. Please consider supporters on Patreon and the many talented that are contributing to fund future content. Researchers, writers, and artists who made this. If you found this topic interesting, check out these related videos about our fascinating past. Be sure to like and subscribe for more history, and check out our description